Let's prove that limit theta tends to 0, sin theta by theta is exactly equal to 1. So we want to prove this equality. However, we will be using inequality. More precisely, we will be showing that sin theta by theta is less than or equal to a quantity nearly equal to 1. Nearly equal to 1. And then sin theta by theta is greater than or equal to quantity nearly equal to 1. And we will use sandwich theorem and say that at the limiting case sin theta by theta must be exactly equal to 1. So let's continue with it. Theta is an angle, so we will draw an angle. To draw an angle, we draw a circular arc. We draw circular arc. We take a compass and draw a circular arc. Let the radius of the circular arc be of unit length. So we draw a circular arc and we assume the radius to be unity. Once again, we draw a circular arc and we assume the radius to be unity. This is just 1 unit. As we said, we are talking about angle theta. Let the arc subtend an angle theta at the center. O be the center. So we got our sector. We know that area of circle is pi r square. So area of sector, area of sector, the blue sector, somehow we want to use theta and sin theta. So area of sector equal to pi r square, that's the area of circle. If we make 2 pi radian, then we get complete circle. So theta by 2 pi times pi r square, and that's simply equal to half theta r square. So far so good, but we got r equal to 1. So this is just equal to theta by 2. Area of sector is exactly equal to theta by 2. Okay, we got some expression involving theta, but we need sin theta as well. To talk about sin theta, we draw a right angle triangle. Once again, to talk about sin theta, we draw a right angle triangle. Okay. So we draw an angle P that measures 90 degrees. Let OPK be a right angle triangle. Can we find the value of PK? Observe that sin theta equal to PK by OK. Once again, sin theta equal to PK by OK, and PK is perpendicular, and PK is perpendicular, so we write as it is. OK is just 1. So PK or KP just turn out to be sin theta. Then obvious question is, how much is OP? OP is OP by OK is cos theta, and OP turns out to be cos theta. So we talked about area of sector in terms of theta, and how about area of this green triangle OPK? Area of triangle OPK equal to half base. Base is just equal to cos theta. Once again, base is just equal to cos theta, and altitude is just equal to sin theta, and area of right angle triangle is half base times altitude. Base is cos theta, altitude is sin theta. Which one is bigger? Obviously area of sector is greater than area of triangle, since area of triangle OPK is less than area of sector. Area of sector, comma, we obtain theta by 2 is bigger than area of triangle, that is half cos theta sin theta. Okay, obviously we assume angle theta to be in anti-clockwise direction, and further we assume that theta is lying between 0 and pi by 2 to make our work easier, comma, theta is greater than or equal to 0. In fact, let's assume just greater than 0, not even equal to 0, and less than pi by 2. So when we assume theta greater than 0, we can divide by theta and say that sin theta by theta is less than 1 by cos theta. Once again, sin theta by theta is less than 1 by cos theta. Okay, we got sin theta by theta is less than or equal to a quantity nearly equal to 1. Can I say 1 by cos theta nearly equal to 1? As theta is nearing to 0, 1 by cos theta is, yes, it is nearly equal to 1. So we did show that sin theta by theta is less than 1 by cos theta, a quantity that is nearly equal to 1 as theta tends to 0. How about the converse? Rather, how about showing that sin theta by theta is greater than or equal to something? So in showing that sin theta by theta is less than 1 by cos theta, we use the fact that area of sector is greater than or equal to area of triangle. So let's say use another fact that area of triangle is greater than area of sector, but such fact is not visible to us. So let's draw a triangle which is having bigger area. Once again, we will draw a triangle having bigger area. Can we draw it? Of course. So we did draw a red triangle with area greater than area of sector. Let this point be M, let this be L. Area of triangle OML, that is, once again it is a right angle triangle, so half base into altitude. OM is exactly unit length. What about LM? You see that tan theta equal to perpendicular by base, or LM by OM, opposite side by adjacent side. LM by OM. Once again, OM is exactly equal to 1. LM is the perpendicular of the right angle triangle. Once again, LM is the perpendicular, and it turns out to be tan theta. Tan theta. Okay, so we got LM to be equal to tan theta. So area of triangle OML is half base times altitude, and that must be equal. Once again, area of triangle is half base into altitude. Area of triangle OML, in fact is a right angle triangle, that's equal to half base. Base is OM, OM is just equal to 1 unit, that's the radius of the circular arc that we have drawn, times altitude. Altitude is LM, and LM turns out to be tan theta. Once again, area of triangle is bigger than area of sector, and area of sector is just theta by 2. Area of sector sector is exactly equal to theta by 2 and area of sector is definitely less than, it can't be equal to, it's definitely less than area of right angle triangle OML, less than area of triangle OML. Area of sector is theta by 2 and we got theta by 2 is less than area of triangle OML is half tan theta, half tan theta. Once again we want to show that sin theta by theta is greater than or equal to quantity nearly equal to 1. So half gets cancelled. So we say that we write tan as sin by cos because we want sin theta by theta. Again we assume that theta is greater than 0, less than pi by 2. And so assume theta is greater than or equal to 0, less than or equal to pi by 2. We can multiply by theta, we can multiply by cos theta, we can multiply by 1 by theta, we can multiply by 1 by cos theta. The inequality will be valid as long as those quantities are positive. Of course, for theta greater than 0 and less than pi by 2, those quantities are positive. So we multiply by cos theta and then we divide by divide by theta. And we say that sin theta by theta is greater than cos theta. Let's call this to be inequality 2. And earlier we have shown that sin theta by theta is less than 1 by cos theta. Let's call this to be inequality 1. By inequality 1 and 2. By inequality 1 and 2. By 2 we are saying sin theta by theta is greater than cos theta, and by 1 we are saying sin theta by theta is less than 1 by cos theta, is less than 1 by cos theta. Okay. So by sandwich theorem, nice name, sandwich theorem or squeeze theorem, comma, since limit theta tends to 0, 1 by cos theta equal to 1. This quantity is approaching 1 as theta tends to 0. And how about the cos theta? As theta tends to 0, cos theta approaches 1, comma, limit theta tends to 0, cos theta is exactly equal to 1. The right hand side of the inequality is approaching 1, left hand side is also approaching 1, so the middle also has to approach 1. We conclude by sandwich theorem, limit theta tends to 0, sin theta by theta equal to 1 for theta greater than 0. We are not complete. What if theta is less than 0? If theta is negative, comma, limit theta tends to 0, sin of minus theta by minus theta is equal to limit theta tends to 0, sin theta by theta. If it is negative, then sine of minus theta is minus sine theta. So negative will get cancelled and minus theta will be positive. So it is true for every theta. So we can say that finally limit theta tends to 0, sine theta by theta is exactly equal to 1 irrespective of whether theta is negative or positive.